All right, everyone, welcome to lesson 3. This lesson is going to be on the topic of the mole. This is kind of a funny sounding term, new term for, I think, almost all of you. This is kind of going to be the way that chemists count atoms and molecules. And so when you think about how big is an atom or a molecule, you know they're teeny tiny, they're invisible to us. So we're going to need to work with massive numbers in order to calculate how many atoms and molecules we actually are dealing with when we perform a chemical reaction, for example. Okay, you want to know how many, how much, what's the mass. You want to know all these different things before you go in and try to do your chemical reaction. So this is all falling under the umbrella of what we talked about in lesson 1, where we talked about stoichiometry, right? We want to make sure we're following the law of conservation of mass when we do these chemical reactions. And that doesn't just mean balancing chemical equations, which you worked on in lesson 2. That also means being able to determine, I balanced my chemical equation, but how many grams of product am I going to make if I have this many grams of reactant, for example, right? So you want to actually be able to do a little bit of math and work with your newly balanced chemical equations when you're talking about chemical reactions in general. So this is still under the umbrella of stoichiometry, right? Lessons 1, 2, and 3 are still talking about counting and measuring atoms and molecules. Okay, so let's get started. There's a few things you're going to need in front of you. Excuse me. A few things you're going to need in front of you before we get started. The first thing you're going to need is a periodic table of elements. Okay, so whether you have it in your agenda, I've linked a PDF to a nice table of elements that you can use for this assignment. You also are going to need a calculator. So if you have one of these guys, right, a graphing calculator or a scientific calculator, that's excellent. You're going to need it. But if you don't, that's okay. You all pretty much have phones in your pockets, right? So if you have an iPhone, for example, you have the calculator app. If you turn it sideways, you get a scientific calculator, right? Or if you have a computer, an Apple computer or a Windows computer, they all have calculators kind of built into their systems. So you need a calculator and a periodic table, okay? In terms of paper, what you need is this Notecatcher here, right? So I attached the Notecatcher in the Google assignment. For this video, the one you're watching right now, you just want the day 1 Notecatcher, right? So it should be 1 page front and back. It has a picture of all these scientists, all these dead guys, and then the back part defines the mole and has you practice a little bit with it. Just day 1 for this video. The day 2, the second part of the notes and the homework will be in the next part of the lesson. So I want to make sure to keep these as short as possible so that you don't have to watch hours and hours of me talking. So you need the day 1 notes, and you also need the day 1, right, worksheet 1 homework assignment. This goes with your day 1 notes. And then the other half of it, right, if you scroll down about a page, worksheet 2 goes with day 2. Okay. So you need day 1 notes. As you're watching this video, take some notes in your Notecatcher, and then you'll practice worksheet 1 with your day 1 notes, and then day 2 with your worksheet 2. Okay, so for now, day 1. Okay, so let's get into the PowerPoint here. Okay, I got I bet some of you thought that I was talking about the animal, the mole, when I was saying mole over and over again. But in chemistry, we're not actually talking about the animal, right? But this is a kind of a cute little drawing of a mole here who's, they're notoriously have bad eyesight, so he's got his blind, like, sunglasses on. So for day 1, we have a few goals, but before we get to that, let's talk about the assignments that you're dealing with in lesson 3. Okay, so there's 3 assignments that make up lesson 3. Now, do you have to do all of them? Absolutely not. The first one, the one you're watching right now and working on now, is assignment 1. This is the introduction to the mole. You can't do assignments 2 or 3 if you don't know what a mole is, for example, right? So you're going to work on day 1 notes, day 2 notes, day 1 homework, and day 2 homework, and that'll be assignment 1. Okay, so watching these videos, getting notes, and working on the practice problems, that's assignment 1. everyone will do that for a grade, right? Everyone will do assignment 1. And then once you get to assignment 2 and 3, then you can actually have the choice here, right? So assignment 2 is more of a creative project where you're actually trying to make word problems like you would do in algebra. You're making word problems to really see and explore how big is a mole, right? And we'll get into this in the mini lesson, but a mole is going to be a massive number. So you're going to make a word problem that might be something like, you know, if I had a mole of Big Macs and I stacked them one on top of the other, how many times could I go to the moon and back, right? And so you'll do a little bit of research to make your word problem. You'll have a little bit of citation you'll have to do. You'll definitely need a calculator. You're going to need these notes that we're taking through these video mini lessons. And you also don't have to do assignment 2 on paper, right? The instructions for assignment 2 are more detailed in the PDF for it, but it says use poster paper or just plain paper. You can use, some of you are really good at using like some Adobe software that lets you, you know, design and draw online, or some of you have your iPads and you're, you know, drawing in class. And so use that technology if you have it, right, to do the drawing aspect of assignment 2. And then you can just kind of screenshot it and send it over that way. Okay, so assignment 3 is for people who are more kind of mystery minded, kind of like mystery, you know, like, you know, true crime show kind of minded people. Assignment 3 is the case of the poisonous pill, right? It's based on true events. And essentially, assignment asks you to investigate the mysterious death of folks who have taken Tylenol, right? One day, imagine you take a Tylenol and they actually start to pass away. And so your job in this assignment is to explore and investigate how this crime might have happened, what molecules are actually causing these people to fall ill. And you'll do that with the skills that you're learning in this lesson and in lesson 4, right? So for assignment 3, you would do maybe half of the mystery. And then in lesson 4, you would do the other half as you get more stoichiometry skills to solve the case of the poisonous pill. So you kind of choose your own adventure, either do assignment 2 or do assignment 3 after you finish with assignment 1. Okay, you don't have to do all 3. If you do all 3, I'll take the extra assignment as extra credit. Okay? So for assignment 1, for day 1 notes, you have your Notecatcher in front of you. We have a few goals. Let's get right into it. The first goal, you want to identify some scientists that helped develop the mole, right? It's important to get a little bit of the history in here as we talk about these new terms and new ideas. Okay, so we want to use dimensional analysis. This is a term you're going to hear a lot more in science going forward if you haven't already heard it, right? How do my units compare when I start to multiply or add them or subtract them? Your units are crucial in science. And so, you know, in your labs, if you didn't have units, I would always circle, where are your units? I need your units. And so you'll see why that becomes more and more important as we get more and more complicated in our math. Okay, and so you're going to calculate how many atoms, literally, how many atoms are in a given situation, how many molecules. We'll talk about formula units. We'll get into that as well, right? So you got a lot of new definitions that you're going to want to jot in your note catcher. Okay, and 1 mole of a substance, what does that mean? Let's talk about it. And then you want to use correct significant figures. Significant figures we haven't talked about in a long time. So we're going to have to kind of touch back on significant figures as we do our calculations, right? So this is very mathy. All right, so let's get right into it. Now, whenever we talk about, for example, if you were to go to the store or you were about to buy something, right? And you needed something like apples or eggs or whatever, right? You go to the store, you buy some food. We can measure things in different ways. You might say, hey, I'm going to go to the store and I'm going to buy 5 apples. Right? That's one way of measuring. We count literally 5 apples. Basically, no one says, hey, I need 12 eggs. Right? If you need some eggs, no one says, I need 12 eggs. People say, I need a dozen eggs. I just need a dozen. I need 2 dozen, 3 dozen. Right? We count eggs by the dozen, for example. Another way we can count other foods, this makes me hungry a little bit, is by mass. Right? If you need some bananas, you might not say, hey, I need 15 bananas. You might say, I need 2 pounds of bananas. or my box of cereal is 16 ounces, for example, right? You use the mass of something to communicate how much of it you need or you want. And then last is volume, right? You don't say, hey, I need 200 grams or half a pound of milk. You might say, I need a gallon of milk. I need half a gallon of milk. I need a pint of ice cream, right? So we use these different ways of communicating and measuring substances. In this case, these are all food examples, but you can do, this with anything. You can do shoes, right? You don't say I need 2 shoes. You don't say I need 3 shoes. You say I need a pair of shoes. I need 2 pairs of shoes, right? So we do this all the time without thinking about it, right? We group things together and we count them, or we take the mass, or we take the volume, and we kind of use that to communicate, okay, this is how much of this I need. Now in chemistry, the mole, right, not the animal, the mole relates all 3 of these types of measurements: counting, the number, volume, how much space do they take up, and then the mass. How much mass do these things we're talking about actually have? Okay, so let's keep talking about the mole here. Now let's go over a brief history here. Okay, and we're going to watch a video in a bit that actually kind of animates this and paints a clearer picture here. But these are some important names to kind of know as you go forward in your chemistry studies. Okay, the first one is going to be a brief history of the mole. The first one is going to be Avogadro. So his name kind of sounds like avocado. So a lot of students, especially last year, were saying, "Oh, I know that guy, avocado." Avogadro, though, an Italian scientist who really spent most of his life studying how gases behave, right? And these cool glass containers. He'd do a lot of cool experiments with gases, changing temperature, pressure, all these things to figure out how do the molecules that make up the gases work, right? So this guy, way back in the day, he thought, okay, look, the volume of a gas at a certain temperature and pressure. So you think about a gas, maybe you might think about a gas in a balloon, right? So if you have 2 balloons that have the same temperature and the same pressure, right? So you're holding them both in your hand, and you think about the volume, how big those balloons are, right? Um, the balloons, if they're of equal volume, if they're the same size, but they have different gases, one might have helium, the other might have, I don't know, neon gas, right? 2 gases, 2 balloons, they're the same size. Those 2 balloons are going to have the same number of molecules of that gas inside, the same number. Doesn't matter what the gas is, right? And this was a really revolutionary idea at the time. And actually, no one believed him. And he actually, it's sad, but he died with no one believing him. Of course, he was right. Okay, so let's keep going. There were kind of 3 more scientists who helped to solidify the idea of a mole. The first one, this guy, Lochschmidt, he basically related the space that molecules take up. If you think about putting more and more of a gas into a balloon, right, it would get bigger and bigger. The volume of the balloon would increase, and so too would the number of molecules of gas inside the balloon. So Lochschmidt really starts to think about, okay, so volume relates to how many molecules there are in something. Right? And that makes sense. If you pour water into your glass starts to fill up with water. There's more and more molecules of water in there, and that the volume of water is increasing. Okay, so the next guy here is Millikan. So Millikan actually measures the charge of an electron for the first time, right? So a lot of these things in chemistry we take for granted. We say, okay, I can look up the charge of an electron, or I can look up how many protons are in this element or whatever. But these little bits of knowledge take a lot of experimentation, and they took a lot of time to discover. So Millikan was the guy who discovered and measured the charge of an electron. And then he related a mole of an electron, right? He takes a bunch of electrons, crams them together, he measures the charge of them, and he's able to relate the charge of an electron to the number of electrons that he has, right? And he uses Avogadro's number. This is something that's going to come up in our mini lesson that will define explicitly. What is Avogadro's number? All right, so the last guy we're going to talk about here is Perrin. I think he's French. He figured out a way to actually compute Avogadro's number using a lot of different methods. This Avogadro's number thing seems to be like a big deal in chemistry. So let's talk about what it is in the slides that are coming forward. He proposed naming this in honor of Avogadro, who, remember, was the Italian scientist way back in the day who first proposed counting and measuring the number of atoms and molecules. And he was right, but no one believed him when he was alive. So after he's now passed away, now we're honoring him by naming it, okay, Avogadro's number. So let's take a look at what we mean by that. All right. So when we talk about a mole, right, we want to make sure that we realize that the way we get a mole, right, the way we define a mole is going to be based on carbon-12, right, the isotope carbon-12. And you know, isotope, right, means that we have carbon and then the mass number is 12, right? And if you look at your periodic table, you know that carbon has 6 protons. And so if the mass number is 12, remember mass number is protons plus neutrons. If the mass number of carbon is 12, then we have 6 protons plus 6 neutrons gives me 12, right? So this is a carbon that has 6 protons and 6 neutrons. Okay. So this is the definition of the mole, right? This is the current most accurate definition of what a mole is. Okay, ready? I want to jot this down. So this is the amount of any substance that contains as many elementary entities, right, meaning atoms or molecules, as there are in 12 grams of pure carbon-12. Right, so this sounds a little bit complicated. It sounds a little bit weird, but what it means is a mole is the number of atoms or molecules that there are in 12 grams of carbon-12. So however many atoms of carbon-12 there are in 12 grams of it, that's what a mole is, right? And that has a very specific number. Okay, so let's talk about, so a mole is, okay, this is it's a new way of thinking about things. Let's define it. All right, so in chemistry, you can write out the mole as a unit, or you can abbreviate it MOL, right? Just MOL, we'll abbreviate it just like you would abbreviate just an M for meters or an F for Fahrenheit. For mole, you abbreviated MOL. Okay, so this is kind of like a bridge between the atomic world that we can't see and the macroscopic world that we can see. In this, in Latin, the mole actually means huge pile. Right? So that's where the word comes from, not actually the animal. I think they were both named after the Latin. Okay, so here's what a mole is. A mole is going to be 6.02 times 10 to the 23rd power. Right? If you know your exponents, you know that 10 to the 23rd power, if you multiply that by 6.02, you're going to get just about 23 zeros that 23 zeros that push that decimal point all the way over to the right. So this is a humongous number, right? So a mole is going to be equal to 6.02 times 10 to the 23. Okay, so that's about 602, and then you add 21 zeros after it, right? So just take a look at how enormous this number is, right? We have to use giant numbers when we talk about things that are so tiny that we couldn't possibly see them. Right, so we're talking about 602 septillion when we talk about atoms or molecules. Okay, and there's a great video that I'm actually going to watch with you here. Right, I want to make sure that everyone actually sees this video because it does a really nice job of painting a picture of how big is a mole. Right, so some of you maybe have would like to have, for example, let's say you want to have $1,000, right? 1,000 would be here. Let's say if someone gave you $1,000, you'd be pretty happy, right? You'd have a 1 right here. What about $1 million? So 1 here, right? If someone gave you $1 million, you'd be pretty set for life, right? Or if someone gave you $1 billion, if you put a 1 here, that'd be amazing. You'd be a billionaire. If someone gave you $1 trillion, oh my God, if someone gave you, what about 1 billion times $1 trillion? Something to think about. All right, so let's take a look at this video. And let's watch it together. I want to make sure that everyone sees this video, so we're just going to kind of watch it together. This one's it's a TED Ed video, so let's take a look at it. Let's see.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your ant's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amedeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now, the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles.
So hold on a second. I know you all love it when I pause the videos, but take a look at this, right? Imagine having to write this on your paper every single time you have to do a math problem with chemistry, right? You have to write out 21 zeros, right? That's why it's so important that we use the scientific notation and that we get more and more comfortable doing it this way and with our calculators as well. So we'll go over that a little bit later.
This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind, Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole, this mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 144, and a ream of paper is, anybody? A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little animal. The only difference is that the other quantities are more familiar to us. So there you have it, the story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
I love that video. The baby throwing the money off. It gets me every time. So this is a massive, massive number. And those of you who choose to do assignment 2 will get a good picture of just how massive the number is, right? In that video, you saw a couple of good examples. What if you have a mole of basketballs or a mole of pennies, right? Those are the kind of examples that you're going to come up with in your word problems. Okay, so we talked about the massive number of zeros. We talked about 602 sectillion. I'll put the link up to this video so you can rewatch it if you want to. So essentially, we're talking about a conversion between number of moles and number of particles, number of atoms or molecules. If I told you, hey, I've got 3 dozen eggs, and then I asked you, how many eggs do I have? You would say, 3 dozen. I would do 3 times 12. I'd get 36. So you have 36 eggs. The same exact kind of math we're going to be doing here, and we're going to be practicing just with bigger numbers, essentially. Instead of using 12, we're going to use 602 sectillion. All right, so let's try it. The first example here, so this is in your Notecatcher, right? If we ask, hey, how many atoms are in 1.22 moles of sodium? So this is like asking, hey, how many eggs do I have in 1.22 dozen? If I have 1.22 dozen eggs, how many eggs do I actually have? Okay, so in these problems, you want to start off by listing what you know and what you don't know. So K here stands for known. So in the case of what I know, my question gives me 1.22 moles, right? I'm abbreviating moles by just saying MOL, moles of this sodium, Na. Okay, so what I don't know though is how many atoms of sodium I have. So if I take a look at, right, and make sure you jot this down so you do this on your paper when you're practicing, right? It's always useful, not just in chemistry, in every class that you do math word problems for. What do you know? What don't you know? And then we start off by jotting down, okay, I know I have 1.22 moles of sodium Na. Okay, so I need to convert this into atoms of Na. And I know, right, ignore the 1 underneath for a second. I know that if I multiply this number of moles by Avogadro's number, right, the 6.02 times 10 to the 23rd, right, this number tells me how many atoms are in 1 mole. Okay, so I want the number of atoms. That's what the question is asking for, right? But I know that for every 6.02 times 10 to the 23rd, I have 1 mole of sodium atoms. So I can multiply my number of moles of sodium atoms times this number, Avogadro's number. And on the bottom, I can put a 1 mole, right? Because I want my units to cancel, right? And you'll see how this works in just a second. I want these moles on the bottom here to cancel out with these moles on the top, so that my units, the only units I want to be left with are atoms of Na. Right? So this is completely fair to do in math because I can put a 1 underneath anything. I can put, if I have this 1.22, I can put a 1 underneath here without changing that number at all. It's the same way you work with fractions in math, right? You can multiply both sides by 1 and you don't get penalized for anything because that's a totally fair move to do in math. Same way here, I can divide by 1 mole on the bottom because I know that these two are the same thing. Avogadro's number is the number of atoms or molecules inside of 1 mole. Just like inside of 1 dozen, you have 12 eggs, right? You would do the same kind of math to figure this out. So once I get my number of moles on the bottom, right, just 1 mole, then I know, because I'm multiplying this by a fraction, I know that what's on top here will cancel out with what's on the bottom here. Okay. And then to do the actual math part of this, I just have to multiply everything across the top by everything across the bottom. Okay. So let's take a look at how to do this on a calculator, right? I've got this problem in front of me. Where do I even start? Let's take a look. Okay, so I'm going to use, for this one, I'm going to use this calculator here. This is the same one you might have, on your phone, on your iPhone. If you have a graphing calculator or a scientific calculator, it'll be exactly the same kind of steps, right? So here, I want to make sure that I multiply my number of moles. So I have 1.22, right? There's my number of moles. And then I want to multiply that times Avogadro's number. Now, this is kind of a tricky thing to get into your calculator, so look carefully here. I want to make sure first that I put in my 6.02. Right? Whether you're doing this on a graphing calculator, scientific calculator, first put that 6.02 into your calculator. And then you want to click on the E button. So in a graphing calculator, the E button will look like this. It'll look the exact same as it does here on the screen, but it'll just be kind of like a button, like this one here. It'll have the 2 capital E's, right? And if it's like above the actual button, like if it's written right above the button, you know, you press Shift or second, and then you press the button to get the E, right? So here, you want to click this double E. What this tells me is that this E stands for times 10 to the something, right? So E times 10, E means times 10 to the, and then you have to fill in the exponent here, right? So I put 6.02, and then the E fills in this part right here, times 10 to the, and then I have to tell the calculator times 10 to the 23rd power. This is what Avogadro's number should look like in your calculator, right? Whether you have the graphing or the scientific, or whether you're just using your phone's calculator, it should look just the same. So then I click my enter button, and guess what? I get the right answer. I get 7.34, and I just round this down. I usually just round down to the 2 decimal places, right? And if we did the scientific, the significant figures, the significant figures, we'd realize that rounding to the nearest 100th place actually works out with my significant figures. So I'm going to take this 7.34. I'm going to round it right here. I have a 4 here, so I round this 4. It stays the same. And then the E, again, remember, this tells you times 10 to the, and then 23rd. So on your paper, you would write 7.34 times 10 to the 23rd after getting this in your calculator. Okay, and remember, though, you're solving for how many atoms of sodium do I have in this many moles, in this many bundles of sodium atoms. Okay, so this is kind of hard to wrap your head around sometimes. So I just want to make sure that you're kind of getting a clear picture of how to solve these problems. And I'll also link a brain pop video at the very end that has some really good visuals. So if you're kind of stuck and you kind of feel like you don't know how to visualize the mole, take a look at that brain pop video as well, because that'll kind of help you get some more good visuals in your mind. Okay, so one more example here. Now we're working the opposite way. Instead of figuring out how many atoms, I want to figure out how many moles, how many bundles are in a certain number of molecules or atoms, right? So Avogadro's number helps me solve that as well. So my known, right, I know, according to this problem, that I have 4.79 times 10 to the 24th molecules of CO. This is carbon monoxide. So I know that I have this massive, incredible number of molecules of carbon dioxide. I want to know how many moles, how many bundles of this CO I have, right? So my unknown then is question mark moles of CO. So then I run through my problem again. First, on the left side, I want to put my my known quantity. So I know how many molecules of CO I have. Okay, and then on the right side, right, you can put your 1 underneath to remind you that you're making this into kind of a fraction problem. So just put a 1 underneath your known quantity, kind of like a placeholder, so that you remember for your second quantity, your right side of your equation here, you're gonna make this into a fraction, right? So this time, Avogadro's number, instead of being on top of the fraction, this time it's on the bottom, right? Why? Check it out. Because Avogadro's number tells you how many atoms or molecules are in 1 mole. And I actually want these molecules to cancel out with these molecules. I want to be left with the number of moles at the end of my calculation. So I put Avogadro's number down at the bottom, right? And then I put the moles on top because I want to be left with moles. And so my molecules will cancel out. That's how I know I'm doing the right calculation here. I know it's supposed to be on the bottom, Avogadro's number, because this molecule cancels out with this molecules. So it's always important in these problems to write your units. You have to write your units because when they cancel out correctly, then you know that you're doing the problem correctly and you can check yourself as you're going, okay? So if we do kind of this calculation, right, you know from your work with fractions in math that we have to take this number and divide it by this number, right? We're multiplying by this kind of reciprocal kind of fraction here. So we want to make sure that this number divides into this number because it's on the bottom of my fraction. So instead of multiplication, this time we're doing division by Avogadro's number. So these problems are going to boil down to either multiplication or division, okay, one or the other. So you kind of have a 50-50 shot. And let's take a look at this problem here. So we clear out our calculator and we do the same thing we're doing before. For the number of molecules, I want to jot down first 4.79. And then I want to use my E function, right? This thing here. And that'll tell me times 10 to the, and then it'll just kind of wait for me to put in the exponent. So for this one, I want to put times 10 to the 24th power. And then I need to divide. So I'm clicking my divide button. And I'm making sure to divide now by Avogadro's number. Right, put the 6.02 and then again, use the E function to the 23rd power. And once I divide those two, I get a number of moles. This is how many moles, how many bundles of molecules do I have? So I want to round this to the nearest hundredth, and I see that I get 7.95, and then I round this thing up because I have a 6 right after the 5. So this becomes 7.96 moles of CO. Okay. So we're working with Avogadro's number. We're either multiplying or dividing to convert from number of molecules to number of moles, from moles to number of molecules. And so on your worksheet, I think this is called a one-step practice, right? So it's because you're only doing one step to get your answer. Okay, and so this stoichiometry will you'll have kind of two-step problems that you'll do, but for now, just practicing going from molecules or atoms to moles, right? Going back and forth between one and the other using Avogadro's number. And so folks, if you're interested in watching the BrainPop video on the moles, it's excellent, completely optional, but remember, you can use this tiny URL to get to the video. And you can log in with this username, cramirez18, and then chem15 amazing. That'll get you access to the BrainPop videos. I encourage you to watch not just this one on the mole, but if you have some other projects that you're working on that you might be confused on, BrainPop has great videos on every subject. So, feel free to look around and search for any videos that you need. Okay, so now, based on those two examples, you're going to work on worksheet 1, right? So this worksheet here, this is your Notecatcher. Your worksheet, that's worksheet 2. You want to work on worksheet 1. Worksheet 1 asks you the same kind of problems. How many moles are in this many atoms? How many atoms are in this many moles? How many moles, right? So you want to practice doing these equations, and you want to practice using your calculator, whether you have calculator on your phone or whether you're using an actual calculator. Doesn't make a difference. Okay. All right, so that's it for the day 1 portion of this. Watch the next video for day 2 and for worksheet 2 practice. Okay, so and then those 2 parts together, that's assignment 1. And so that's mandatory for everybody. And then after you finish those 2, you'll work on assignment 2 or assignment 3. All right, so good luck. I'll see you in part 2 of this video lesson.